All right, so really these two videos could have gone together because this is going to be that example of the one in your recommended practice questions, number 45, where you're starting with a quartic function, but we're going to take it one step further that once you've factored your polynomial function, you are going to sketch using the zeros. And so I kind of wanted to break it up just to give you a chance to break and practice. But yeah, you might need this video. So for this one, we've got this quartic function, so a highest degree of 4, but the process is going to be the same. So step number 1, we're going to determine what are my potential zeros. So it's the potential zeros of 24 again, so we have plus or minus 1, 2, 3, 4, 6, 8, 12, and 24. And then we're going to use the remainder theorem. Now again, if you're really into synthetic and you're like pretty confident you've got the zero, you could go right to synthetic because then you get your quotient at the same time. But this is what I do. Now again, I'm going to look at this and I'm going to see if I should try a 1. I'm going to also see if it should be a positive 1 or a negative 1. So I've got this negative 24 again that I need to balance, but I have this huge positive 34. Without actually doing it, I don't know. Maybe it'll be plus 1. Maybe it'll be negative 1. I'm not sure. I think, no, it can't be negative. If it was negative, then you'd have 34 times a negative, which would come out negative, and then you'd have a huge negative to balance. So it's not going to be any of the negatives. So let's go positive. I'm going to try 1 to start with. So I'm going to have 1 to the 4. That doesn't look like a 4. Minus 4 times 1 cubed, minus 7 times 1 squared, plus 34 times 1, minus 24. I'm going to plug that into my calculator. Okay, I've got 1 minus 4 minus 7 plus 34 minus 24. Yes! Maybe I did this on purpose. So then we get to move on to step 2. Step 2, we're going to write our synthetic division with that number in the box, and then we're going to write our line across. We're going to pull off our coefficients. Now, does it go descending orders of power? So 4, 3, 2, 1, gone. Yep. So I'm going to go 1, negative 4, negative 7, 34, and negative 24. And again, I'm going to do the whole process. I feel like I'm just going to be quiet. Maybe pause the video and just try this on your own. Awesome. And so now what I've done is I've taken my quartic function down to a cubic function. Now, like I did in the last one, I usually try to remember to do this at the beginning. I'm just going to kind of give myself a little bit of space here. I really do like sort of just keeping track of my factoring as I go. So now this is going to be my linear factor. So it's going to be a factor of x minus 1. And then I'm going to be left with this as my quotient. So I've got an x to the 3 minus 3x squared minus 10x plus 24. Right? Because we did a quartic divided by a linear, so we took it down to 3, or constant x, x squared, x cubed, totally up to you. Now here's one where we're at a cubic. Well, I can't factor a cubic function. I mean, unless I could do it by grouping, but if I take an x squared out of here, I'm left with x minus 3. I'm never going to be left with x minus 3. So I get to go back to step 1. Now, again, it's 24. So what we're going to be trying to do is we're going to be trying to factor this new cubic function. So we're trying to factor x cubed minus 3x squared. Sorry, I was just having a brain fart. I was like, maybe I should write this. Maybe this should be part of the process because you can kind of see it, right? If I wrote that here, then you could kind of see it breaking down as you go. So in the first 2 steps, we took our quartic function down to a cubic function times a linear function. So we've got x minus 1, x cubed minus 3x squared minus 10x plus 24. Right? And now we're trying to factor this cubic function. So the linear is just going to come along for the ride, right? So from now on, we're going to have this linear function, and then we're going to get another linear function, but it's going to be times a quadratic. And then lastly, we'll have the linear functions all multiplying together. So I feel like this is good to keep up here. It's kind of like your framework, but maybe this is as we go. So now what we're going to do is look for numbers that are factors of 24. So we've got plus or minus 1, 2, 3, 4, 6, 8, 12, and 24. And we're going to try them. So F at, now again, always give yourself a bit of a leg up. So we've got this positive 24 we need to balance. I really don't think negative 1 is going to work, but I'm going to try it. So that's going to give me negative 1 cubed, which is negative 1, minus 3 times negative 1 squared is minus 3, and then I'm going to have, ooh, right, I should have looked at that. Negative 10 times negative 1 is positive 10, and a positive 24. Okay, I failed. That's okay, it happens. It doesn't equal 0. So now should we try 1? I don't think that's ever going to work, because if you look at these numbers, even if I could keep this as a negative 10, it's not going to work. So I'm going to try 2. I'm going to plug in a 2 and hope it works. So I'm going to have 2 cubed minus 3 times 2 squared minus 10 times 2 plus 24. Let's see what I got. So I've got 8 minus 3 times 4 minus 20 plus 24. Oh, ha, ha, look at that. 0. So then I get to move back on to step 2 again. Taking up way too much room here. We're going to have to see how I do this. So step 2, you're going to take that 0 and you're going to plug it into your synthetic division. We're going to pull off our coefficients. So we've got a 1, a negative 3, a negative 10, and a 24. And then we bring down and we multiply and we add. I'll stop talking. Okay, so what we did is we've now taken that cubic function and we've factored it down to x minus 2, and then we've got x squared minus x minus 12. Right? So we've got, this is the linear, this is the quadratic, and then we're almost done. So let's go back up here and say, okay, I've taken it down to x minus 1 times x minus 2, and then I'm going to factor this guy. So I'm looking for two numbers that multiply to give me negative 12 and add to give me negative 1, which are negative 4 and 3. And if I'm going too fast, just pause your video. Then what I always do now is kind of look at this and see if there's any common linear factors, because then I'll write them as squared or cubed. But this one has 4 distinct linear factors. So because this asks me to sketch, now that I've factored it, I'm going to state the zeros. So my zeros were 1, 2, 4, and negative 3. And they all have multiplicities of 1, which means every single one of these x zeros or x-intercepts, we are going to pass through the x-axis. Does it feel like forever since we sketched? And then what else do we need to know? So we know that if we were to sketch this, right, we don't really need the y-axis. I mean, you can put it there if you want, but we're going to put these x values on my x-axis. I feel like it makes people feel better if I make it an xy plane. So I'm going to have an x-intercept at negative 3. I'm going to have another x-intercept at 1. I'm going to have another x-intercept at 2. And then lastly, I'm going to have an x-intercept at 4. What else do I need to know? I need to know where to start. So we go back up here. This is an even function, and it's got a positive coefficient. So it's going to start in quadrant what? Right? You're picturing your parabola that starts in quadrant 2, and it's going to end in quadrant 1 if we do everything properly. So I'm going to start up here somewhere, doesn't matter, and I'm going to take this and I'm going to go through, I'm going to go through, I'm going to go through. Yay, I ended in quadrant 1, and I'm going to add the arrows onto the top. Awesome. So this one gave you an example of how to do a quartic function in its factoring, as well as then reminding you how to sketch a polynomial function.